Hello students, I welcome you all as far as this online lecture series is concerned, as far as this e-class is concerned. Last time we were talking about versatile nature of the carbon. As far as last video lecture is concerned, we are talking about versatile nature of carbon. Last time we were talking about versatile nature of the carbon. In versatile nature of the carbon, I told you people, carbon is having two important characteristic properties. One is property of catenation. One is property of catenation and another is property of tetravalency. It is because of these two properties, carbon forms millions and trillions of the compounds. I told you people in the previous lecture that at least 5 million organic compounds are known. It's because of these properties, property of catenation. This property of catenation is also called as property of self-linking. It's because of this property of self-linking, carbon atoms can join with other carbon atoms in long chains, I can say, to form millions and trillions of the compounds. And as far as this tetravalency is concerned, tetravalent carbon is having valency of 4. And according to the Liebel and von Hoff, they said that the 4 valencies of the carbon, this like this 1, 2, 3, 4. And they said that the 4 valencies of the carbon are directed towards the 4 corners of the regular tetrahedron, giving this carbon a tetrahedral structure. Tetrahedral structure with tetrahedral angle equal to 109 degrees 28 minutes. So, versatile nature of the carbon, we discussed this, and I told you people it's catenation and tetravalency of the carbon which enables the carbon to form millions and trillions of the compounds we people are seeing around. So, let's discuss one more topic, one more subtopic, that is occurrence of carbon. It's like this, occurrence of carbon. As far as carbon is concerned, carbon can occur in 2 states. One is free state, and another is combined state. So as far as this free state is concerned, free state simply means this native state, also called as uncombined state. Whenever I talk about the free state, I told you people carbon can occur in 2 states. One is free state, another is combined state. But as far as carbon is concerned, it's mostly, I can say, present in combined state rather in free state because of its meager, I can say, amount as far as Earth's crust is concerned. 0.02% of carbon is present in Earth's crust. So as far as free state is concerned, this is also called as native state, also called as uncombined state. Now the question arises, what is free state? What's uncombined state and native state? It's free state means free carbons, means carbon is present in isolation. And as far as nature is concerned, as far as free nature of the carbon is concerned, we have 2 important, I can say, allotropes of the carbon. One is diamond and graphite. And these 2, I can say, allotropes of the carbon are in the free state as far as free state is concerned, because diamond and graphite, they are totally, wholly or solely made up of the carbon, free carbons. Free carbons like this, that also mean, whenever I talk about the free, that also means free means not in combination with other elements. That means it's not in a state to form compounds and all that. It only forms structures like this is diamond, graphite. These are the solid structures of the carbon. That carbon can form 2 structures. One is diamond and graphite. Another, recently, one more structure has been discovered recently, that is Buckminster ring. Buckminster is C6, that's soccer ball, also called as Bucky balls. That means 60 carbons can join with each other to give a structure that's also called as soccer ball, or I can say Buckminster ring. So as far as this free state is concerned, now the question arises, what's free state? Whenever I talk about the free state occurs mainly in 2 forms. One is diamond and another is graphite. Now the question arises, why free state? Because carbon is present in isolation. Isolation means only the carbon atoms are present, not in combination with the other atoms. So free state carbon can occur in diamond as well as in graphite. And recently one more allotrope of the carbon have been discovered, that's Buckminster fullerene, also called as the soccer ball, also called as C60, because 60 carbons can join with each other to give a definite structure, and that solid definite structure is called as Buckminster fullerene. Now another thing, that's combined state. Whenever I talk about the combined state means that carbon is in combination with other elements. Carbon in combination with other elements to form compounds. Whenever I talk about, I told you people that carbon mostly is present in the combined state. Let me give you some examples of the combined state in which carbon is in combination with other elements. Like we have in first lecture in organic chemistry, when I delivered the first lecture, the carbon and its compounds, I told you people there that every single thing in this universe comprises of the carbon, but this carbon can be in free state and it can also be in a combined state. But as far as combined, I told you people that mostly carbon compounds are in combined state because they, I can say, form long chains. They join with each other to form new compounds, and it's because of this combined state you are seeing the millions and trillions of the carbon compounds. So carbon is in combination with other compounds, other elements to form the compounds. First thing, that is in atmosphere. Whenever we talk about the carbon dioxide, that's carbon dioxide in atmosphere, in air. It is carbon in combination with oxygen, that's combined state of the carbon. And whenever I talk about these carbonates, we have carbonates, that is limestone, we have marbles, we have chalk, etc. That's carbonate, CaCO3, that's calcium carbonate, that's calcium in combination with oxygen in combination with carbon. That means carbon in combination with calcium in combination with oxygen. And whenever I talk about these organic compounds, we have fats, we have minerals, we have vitamins, we have proteins. You will see the long chain of carbon atoms in combination with other elements to form the fats, to form the minerals, to form the vitamins, to form the minerals. As far as glucose is concerned, glucose C6H12O6, that's carbon in combination with hydrogen in combination with oxygen. That's carbon is present in the combined state. Now second, we have sucrose, that's sugar, C12H22O11, that's carbon in combination with hydrogen in combination with oxygen. And we have one more example, that is, I can say, starch, the reservoir food material as far as plants are concerned. That is C6H10O5 whole N. That's glucose units have been combined. I can say they combine to form the starch. Glucose monomers have been combined or have been joined with each other to form the starch. And it's because the starch plants, I can say, grow during these, I can say, winter season. Whenever I talk about this starch, this is reserve food material as far as plants are concerned. So carbon can in combination with other, like we have, I can say LPG. LPG contains C4H10 butane units. That means carbon in combination with hydrogen. We have petrol. I am talking about fuels. We have petrol, that is C8H18 octane units. That's carbon in combination with hydrogen. Whenever I talk about this, I can say methane. Methane, that's Mars gas, CH4. Formula of the methane, that's carbon in combination with hydrogen. So carbon is mainly present in the combined state. So this was the occurrence of the carbon. Hope you enjoyed it. Next lecture we are going to discuss the allotropes of the carbon.